Welcome to my channel, and today I'll teach you how to find the universe of higher order matrices using row reduction, or I can say using Gauss Jordan method. So that's the method I will use today. In the last video we looked at how to get inverse of higher order matrices by using the method of adjunct. So to use this row reduction method, what we must understand is that we'll be carrying out elementary operations. And what this method says is that supposing I was to write A and then with the inverse, now A with the identity matrix. If I was to write A with the identity matrix, then there will exist elementary row operations that will take A to the identity matrix and then take the identity matrix to the inverse of A. That's what we'll be doing. So we'll be carrying out elementary row operations and ensure that we make this matrix A to become the identity matrix. And those same elementary row operations are performed to the identity matrix, and they carry it to the inverse of A. So let's use an example to make it clear. The question is, use row reduction to find the inverse of A when A is this. So we're using row reduction. So what we do, we write the matrix that we've been asked here. And then there's this vertical line, write the identity matrix. This is a 3 by 3 matrix, and therefore we'll write here the identity matrix, a 3 by 3 identity matrix. So we carry out operations, elementary operations on this to transform it to become the identity matrix. So the elementary operations that we'll be doing on this matrix, we'll be doing them also on this matrix. So when this one becomes the identity matrix, this will have become the inverse of A. So let's just do that. So I have this element here, this element 1. I want to use it to have zeros elsewhere in the column, so that this 1 is the only non-zero element in column 1. So I want a 0 here, another 0 here. So what you notice is that to get the new row 2, I'll have to take the current row 2, then add row 1 to it. Let's do that. So row 1 remains where it is. So add row 1 to row 2, you have a 0 here. Add row 1 to row 2, this 2 plus negative 1, you have negative 1. This negative 4 times, plus 3, you have another negative. What was this? This gave us 1. When you add this 2, and when you add this 2, you have negative 1. When you add this 2, you have 1 here. And when you add this and that, you have 1. When you add this and that, you have a 0. So we also require 0 in this third row position, third row column 1 position, this third row column 1 position. So to get a 0 here again, you notice that we shall have to add row 1 plus row 3. That's what I wrote, row 1 plus row 3. So 1 plus negative 1 is 0, 2 plus negative 2 is 0, and then negative 4 plus 5 is 1. 1 plus 0 is 1. 0 plus 0 is 0, 0 plus 1 is 1. So I have this. Now, so the next thing, I'm done with the first column. So I count the second column, and I have this, in this second row, second column, I have this element. I want this element 1 to be the only non-zero element in column 2. I want it to be the only non-zero element in column 2. So I need this to be 0. This one is already 0. So we are very much fortunate here. This one must be 0. So for us to have this become 0, what are we to do? We're supposed to take row 1 minus 2 row 2. And this should be our new row 2. So row 1 minus 2 row 2. So that means 1 minus 2 times this will remain to be 1. 2 minus 2 times this will be 0. That's the 0 you are seeing there. And then negative 4 minus 2 times negative 1. This will be negative 2. And then we come to this 1 minus 2 times 1. And that should be negative 1. That should be negative 1, you see there. And then 0 minus 2 times 1. That should be negative 2. Then finally 0 minus 2 times that will be 0. So you have this matrix. So you have this matrix, and you can see we've achieved that we have a 1, then zeros below it. Then we have this 1, then zeros above and below. So we now come to this element and use it to create zeros elsewhere, so that it's the only non-zero element in this column. So what are we to do? And I've written here that for us to achieve that, we shall require row 2. The new row 2 will be row 3 plus row 2. What about here? To get a 0 here. To get a 0 here, we require this row 1 plus 2 row 3. This element plus 2 times this gives us a 0 there. So that's what I did. So this row remains what it is. This row remains what it is. We only want to affect row 2 and row 1. So let's begin with the row 2. To get a 0 in this position, we say we are adding row 3 plus row 2. So this 1 plus this negative 1 gives us 0. This 1 plus this 1 gives us 2. This 0 plus this 1 gives us 1. And this 1 plus this 0 gives us 1. So we are done with this row. So you come to this other row. Remember that we are taking, remember that for us to get a 0 in this position, we are taking this element times 2, then add to this. So this times 2, we get 2, plus this, you have the 0. This times 2, you have 2, plus this, you get 1. This times 2, you have 0, plus this, you have negative 2. This times 2, you have 2, plus this, you get 2. So we've achieved what we wanted, because you notice that the first matrix here has become identity matrix. It has become identity matrix. And so we said once this becomes the identity matrix, whatever shall be here will be the inverse of matrix A. So in other words, the inverse of matrix A is this matrix 1, negative 2, 2, 2, 1, 1, 1, 0, 1. This is the inverse. The method that will be used is row reduction or Gauss Jordan. So let's look at another example, just one, to make it clear. And this is the example. Use Gauss Jordan method to find this inverse. So again, we're just doing the same thing we've been doing. We have this matrix, and then beside it, we write the identity matrix. Do elementary operations on the entire matrix. When this becomes identity, whatever will be here will be the inverse. So remember that for us to make this an identity matrix, we require this element to be 1. So that's the first thing I do. I make it 1. There are various ways of making it 1. We may want to subtract this row 3 from row 1, and this will be 1, will become 1. Or just simply do what I did. I divided row 1 by 2. I divided row 1 by 2. So when you divide row 1 by 2, this one becomes 1, a half, negative 1, a half, 0, 0. So this is the matrix we then get. We use this one that we created to have zeros elsewhere in column 1. So you need a 0 here and a 0 here. So how do we achieve a 0 in row 2? I've said that to get a 0 in row 2, you'll take row 2 minus 3 row 1. And to get a 0 in this position, we'll take row 3 minus row 1. So let's just do these operations. So this element times 3 subtracted from this, you have a 0. This element times 3 gives you 3 out of 2. Subtracted from negative 3, this gives me negative 9 over 2. Because the LCM here will be 2. And this will be negative 6, then negative 3. So it's negative 9 over 2. So, okay. So we are done with this. Now this element here times 3, you get negative 3. And then subtracted from negative 1. Subtracted from negative 1. So this becomes positive. And that's why you have 2 here. Do that for the entire row, and you have this. You get this. Do it for the entire row, because I've also multiplied this by 3 to get 3 over 2, and then subtracted from 0. So I have negative 3 over 2. So I'm doing it the entire row. Now come to row 3. We've said we shall take row 3 minus row 1. So 1 minus 1 gives us 0. Negative 2 minus a half gives us negative 5 over 2. And then 3 minus 1 gives us 4. So you do it for the entire row, and you have this. Now, so the next thing is to create a 1 in this position. So how do you create a 1 in this position? By multiplying row 2 by negative 2 over 9. So multiply row 2 by negative 2 over 9. So you multiply the entire row by that, and that will give you 1 in that position. Because we want this 1, and then use it to create zeros in these other positions. So let's see what happened. Yes, so that's what I did. I just multiplied row 2 by negative 2 over 9. So when that happens, this by negative 2 over 9 gives me positive 1. This by negative 2 over 9 gives me negative 4 over 9. And this one by negative 2 over 9 gives me a third. And the other one will give me negative 2 over 9. And the other one will give me 0. Now, once I have this one, I use it to create 0 in the other positions in column 2. So I want a 0 above it and a 0 below it. I want a 0 above. So I come here. How do I get a 0 here? So for me to get a 0 here, I require that I take row 1 minus a half of row 2. That's what I wrote. And for me to get a 0 here, I require that I take row 3 plus 5 out of 2 of row 2. And that's what I wrote here. So let's do those operations and see what they yield. So row 2 remains where it is, because it's the one we are using to create zeros in this position and this other position. So row 2 remains where it is. So a half of this subtracted from this a half gives me 0. A half of this subtracted from this -1 gives me -7/9. A half of 1/3 subtracted from a half gives me a third. And then a half of this subtracted from 0 gives me 1/9. A half of 0 subtracted from 0 gives me 0. We want a 0 here. They said we'll take 5/2 of this plus this. So 5/2 of 1 plus 5 plus this gives me 0. 5/2 of this plus this gives me 1. You can just work out that one, because this is 4 plus 5/2 of -4/9. And you'll see that 2 go here -2 times. So what we have will be 4 minus 10/9. And that the LCM is 9. And this will be 36 minus 10, which gives you 26/9. Which one was that? It was, where are we? Yes, that 26/9 here. 26/9. So I think I was pointing at at a different value. It's this 26/9. 26/9. So 5/2, we are done with this. 5/2 of this, then plus this, gives us that. So you do it for the entire row, and this is what you get. This matrix. Get that matrix. Now, so the next thing, we have a 1 here, we have a 1 in this position, we require a 1 in this position. So how do we get a 1 in this position? By multiplying row 3 by 9/26. So row 3 by 9/26, the entire row 3 by 9/26. This will be 1. This will give us 3/26. This will give us -5/26. And this will give us 9/26. Now that we have this one, we want to use it to create a 0 in this position and another 0 in this position. So how do we get those zeros? And that's what I wrote in my next step. My next step, I said that to get a 0, in this position, I'll take row 2, the element in row 2, plus 4/9 of element in row 3. So the element in row 2 plus 4/9 of element in row 3. I do it for the entire row. And then for me to get a 0 in this position, I'll take the element in row 1 plus 7/9 of the element in row 3. And I do it for the entire row. And that's what I wrote here. So when you do that, you achieve this matrix. That's the matrix you achieve. Now you can see that we have achieved the identity matrix in this position, so that whatever is here is the inverse that we wanted to get. So that is the inverse. And that's what we have. So that's how we use Gauss Jordan or row reduction method to find the universal matrices.